A student sent me this problem to go ahead and solve. And if you've ever solved a system of equations with 3 variables using the elimination method, you know it's not always that fun. So I kind of felt nice, and I was like, you know what, let me do the hard work for you, and let me show you the way that I like to approach these problems, so hopefully it can help them out as well as help you out. Okay, all right, so that's actually a 3. Sorry, I rewrote it wrong. So here's our system of equations. And again, you could use elimination or substitution. The student asked me for both, and I'm like, all right, you're getting a little too greedy. I will go through what I feel like is the optimized process for an equation like this. And in that case, it's going to be elimination. I only like to use substitution if I have a variable already eliminated. That will make your life a little bit already easier to do the substitution method for systems of 3 equations. But when we have all the variables, I just prefer to use elimination. And remember, the elimination method, basically what we need to do is we need to choose a variable to eliminate. So typically I like to choose variables that already have a 1 or a negative in front of them as their coefficients, or they are like the smallest subset. So I look at here, I have 3, -4, and 5. That doesn't seem too bad. I can work with that, but not ideal. This one looks promising though. -2, 1, and -3. I like that a lot. And then 4, 5, and 3, that can work, but you know, again, our multipliers are gonna get pretty big for us to get common factors. So let's focus on this. Now, when I'm going to be dealing with them, I'm going to label my rows as, or equations as equation 1, equation 2, and equation 3. Okay, and what we simply need to do is we need to use elimination to eliminate our variable between the first 2. So we can eliminate here, and then the bottom 2, 2 and 3, and we can eliminate y there. That's going to create 2 different equations, which I am going to label as A and B. Okay, so to find A, what I'm simply going to do is I am going to eliminate y from equations 1 and 2. Now, before I can go ahead and do that, I recognize though that I need to eliminate something. I need the coefficients to be exactly the same. And if I'm going to use the addition method, I want one to be positive, one to be negative. The reason why I like this is we already have, these are negative and that one's positive. So all I simply need to do in this case is multiply my equation number 2 by a 2. So I'm going to multiply everything by equation number 2. So therefore, it's going to have a positive 2 for the coefficient of y. Now, let's go ahead and rewrite equation 1 first, since we're not doing anything with it. And then when I multiply by 2 over here, just to save work, you could multiply it, show your work, multiply it out, but I'm just going to go ahead and rewrite everything. So I have a -8x plus a 2y, 2 times negative, that's a -10z, and that's going to be equal to a -70, that's a 35. Be very careful, Ms. McLogan. You see the mistakes I'm always trying to make? And that's going to be a 72, right? Okay, so just make sure, it'd probably be better to work out yours, but since I have limited space here, I'm going to try to keep everything right in front of me. Okay, so just make sure you multiply by everything. That's a common mistake students will make. They'll multiply and they'll forget to multiply 1. All right, so now, since I have the coefficients, everything's aligned, and I have 1 negative, 1 positive, the exact same number, I can now go through the elimination process by adding the 2 equations. So by adding the 2 equations, I'm now going to get a -5x. That's going to go to 0. That's going to go to a -6z, and 35 plus a -72, that's going to be a -37. So -37. Okay, now this equation I'm going to label as my A. That's my A equation. For B, I'm now going to eliminate equation y from the equation 2 and 3. Now, in this case though, I have a -3 for my coefficient of my y in equation number 3. So rather than multiplying everything by a 2, I'm now going to multiply everything by a 3. Okay, so again, I'll go ahead and rewrite that up first, then we'll keep equation number 2 over here. So actually, let me just go and do, this is equation 2. No, that was equation 1. And this was equation 2 times equation 2. Okay, so I had 2 times row, and you could think about, I was going to do like row 2, 2 times row 2, which again, that kind of gets into going back into your Gaussian eliminations and matrices, which probably would be okay, but I'm assuming if you haven't got to that way, we're just doing 2 times row 2. So let's go ahead and rewrite a 3 times my equation number 2. So that's going to be a -12x plus a 3y minus a 15z equals a -108. And then I have equation number 3, and that's just going to be written the same. 5x minus a 3y plus a 3z equals to a 31. Okay, so again, I have these being exactly the same, right? So now I can apply my elimination method. And again, this is going to give me equation number B, or letter B. So add them all up here. This will give me B. Add them all up. This will give me a negative 7x. That's going to go to 0. This is going to give me a negative 12z. And that's going to be a 77, so negative 77. OK, so now I have an equation with just x and z's, and I have another equation with just x and z's. Now I can go ahead and solve for x and z, right? It's a system of equations with two variables. So now I'm simply just going to take my a and my b, and I'm going to rewrite them over here. So if I rewrite this, it's a negative 5x minus 6z equals negative 37, and that's a negative 7x minus 12z equals negative 77. OK, so now what I need to do is I need to go ahead and pick again another variable to go ahead and isolate, to go ahead and solve for. Typically what I would say is, well, since all I got to do to get these to be the exact same, I can just multiply my a times a 2, or a negative 2, and then this would be a positive 12. So that would work, right? So if I multiply this equation by a negative 2, I'm now going to get a, let's go ahead and rewrite this. So now what I'm doing is multiplying a negative 2 times a, and then we're going to rewrite b. So when I do that, I'm going to get a negative, no, sorry, it's a positive 10x plus a 12 times z, so that's a 12z, and then therefore that's going to equal to a positive 74. And then over here, that's going to remain the same, so that's a negative 7x minus a 12z equals a negative 77. Now again, I can add these together, and that was my red, no it wasn't. So now you can see they have one positive, one negative, so I can now add them. This is going to give me a 3x equals to a negative 3. Divide by 3, divide by 3, x is equal to a positive 1. So wait a minute, that's a positive 3, that's a negative 3. That's supposed to be a negative 1. There you go. X is going to equal to a negative 1. All right, so now that I know what x is, I can simply go and solve for z. But I don't want to go back over here because I also have my y. I don't want to go over here. I want to choose one of the equations where my y was already eliminated. I'd probably say the quickest answer would be using this equation right over here. So I'm going to let x equal negative 1 in the equation a, and then go ahead and solve for z. So when I'm doing that, I'm going to have a negative 5 times a negative 1 minus a 6z is equal to a negative 37. So this is going to be a positive 5 minus 6z equals negative 37. I can go ahead and subtract a 5, negative 6z equals a negative 42, divide by negative 6, divide by negative 6, and z is equal, that's really bad writing, sorry, I had my marker storage, divide by negative 6, z is going to equal a positive 7. All right, we're almost done. So I have x, I have z, I just now need to go ahead and find y. So what I'm going to do is I'm going to plug these two values into my middle equation, because then I already have my y basically isolated. So that's the easiest to do. I kind of ran out of space here, so sorry, I'm going to go ahead and plug everything in right here to go and solve for my y. So I'll do a negative 4 times a negative 1 plus y minus a 5 times z, which is 7, equals a negative 36. Well, this is going to be a positive 4. This is going to be a negative 35. And then that's going to equal a 36. I can add a 35 to both sides. That's a negative. So I have a 4 plus y equals, that was a negative 36, right? So therefore, that's a negative 1. Subtract 4, y is equal to a negative 5. So I have y equals negative 5, x equals a negative 1, and z equals a 7.